Well, hi, my name is Antoine. I'm 26 and I'm French. I was part of the fourth Emerald cohort, so I graduated 2 years ago in 2018. Before I was studying at Nancy School of Geology. This is where I heard about the master. And I was looking for an international environment, to study abroad and see how it was elsewhere. And looking back, I'm really glad I enrolled, having a lot of good memories, especially about the field trip we had in Spain and Scandinavia. For me, it was the first time I saw operating mines. So a very good experience, and I really learned a lot in this master. A few days after the graduation ceremony, I started to work for Orano, which is the French national nuclear company focused on the nuclear fuel cycle. And I was sent for 2 years in Kazakhstan. I actually just came back. Alors why? Well, you have to know that Kazakhstan is more than 50% of the uranium world production today. They are operating around 15 mines, all employing in situ leaching or in situ recovery. So it's a technology which is different from traditional mining with open pit or underground, because you do not have any mineral processing. You directly dissolve the minerals in situ, okay, in the reservoir. You simply pump the pregnant solution. So on the ground, you have kind of a Super Mario network with injecting and pumping wells in a kind of closed circuit with the plant and the reservoir. So it is somewhere between the mining and the oil and gas industry. As in the oil and gas industry, the key challenge compared to traditional mining is that you're completely blind. Apart from few drill cores and some geophysical information, you don't know much, and you never have access to the deposit, even afterwards. So you're dealing with a black box. You know what you inject, you know what you pump, but you cannot measure or see what's happening inside. Okay, and you might dissolve somewhere and produce elsewhere because you don't completely control the flows. And this is why we do reactive transport modelization. So we simulate at the same time the hydrodynamics and the chemical reactions between the fluid and the rock. The overall process is very like what we studied, similar to the serious games we played back in Luleo. So the geometallurgy and this global approach. So first you have a deposit, a reservoir, you characterize it, you transform chemical assays into mineralogy, geophysical data into properties. From that you build a 3D block models. Of course, the descriptors vary. For instance, instead of the bond work index, you're interested in the permeability, the dynamic porosity. Then you build you imagine mining sequences, you simulate all that with an associated cost model, and in the end you obtain net present values. You can compare mining sequences, quantify uncertainties, decide where to invest money to increase the reliability of your models, and of course take operational decisions. So you can see that the principle and the philosophy remain the same. I've been doing that for the past 2 years in a mine named Catco, which is actually the biggest ESR mine in the world. It was fly in, fly out, quite intense. But I really enjoyed working there, with this big picture approach. And Kazakhstan is definitely a paradise for geologists, with very friendly people and amazing landscapes. And if you have the opportunity, you should definitely visit it. What's next? Well, very soon I will start a PhD. I will keep working for Orano on the application case of Catco, still on the in situ recovery modelization. You have to know that in order to qualify our simulation, the best is to reproduce some past production history and to compare the results with the true value. The problem is that when it's bad, and if we don't have any additional geological information, so we cannot upgrade the 3D block model, well, there is nothing we can do. It's bad, it's not predictive, and that's it. So what I will try to do, my goal, is to use this past production history as an input to upgrade the 3D block models. So it's an inverse problem resolution where we use this production data as an input to improve the knowledge of the geology, and so to be more predictive, because in the end the goal is to be predictive and to predict what will be the production in 6 months, in 1 year, in 10 years. So this will take place in Paris, between Orano and the Paris School of Mines. And after that, I don't know, I guess I would love to go back on site, on a mining site, not necessarily in situ recovery. I would say in the future.